I'm happy to have so many people here in this webinar from all over the world. And well, we only have 1 hour in order to deal with a very complex issue. So I'm going to dive right into the subject. And already as a preliminary note, I of course won't have time to go into each and every detail. So I will give you an overview of the key pillars of electricity markets with high shares of wind and PV. And of course, you have my contact details, and I'm glad to discuss more details with you at the end of the session in our Q&A session, but also in the coming days via email or phone. Yeah, so Fernanda already introduced me, so I don't have to do this again. However, I would like to take the chance to introduce the Clean Energy Solution Center. I'm doing this in cooperation with the Clean Energy Solution Center, which has been founded back in 2011 by the Clean Energy Ministerial as a sort of one-stop shop agency for governments around the world to design their policies for clean energy technologies. They have a lot of partner organizations, 35 partners around the world, also including the major international organizations. And it is actually a very useful tool for policymakers in developing countries because they will assist you with all kinds of questions that you might have related to energy access, energy efficiency, renewable energy, smart grids, transportation, or utility policy. And the best thing about it is that all of this will come to you at no cost. So you actually have the chance as a policymaker, so you have to be engaged in some government organization. If you have any questions that you're dealing with and you don't have an answer right straight away, you can actually go to the Clean Energy Solution Center, go to the website, and simply type in the question that you have, and then they have a pool of experts, including myself, from all over the world, and they direct it to the best experts that they have in their pool. And then in a very short time period, you get an answer to your question, which you might not have been able to solve internally. So they've already given advice to more than 75 countries now around the world, more than, I think it's today, more than 200 requests worldwide. So it works very well, and it actually bridges an important gap that we saw. There's of course a lot of donor initiatives, but normally applying for the money takes a long time, and then until the project starts, half a year might be gone. And this actually helps you with your day-to-day work. So if you have a very short-term question and you have no time to wait for a large-scale international organization to give you funding in order to get an answer, the Clean Energy Solution Center is where you want to go. And as I said before, you just go to this website that you see here. You can type in your question, you send it off, and the next day expert will be dedicated to you who will help you in responding to the question that you have. So I think that's a very useful tool. Also keeping in mind that now with the Paris Agreement, there's probably more and more countries around the world which have to act more urgently on climate change and also on upscaling renewable energy. So that I think this will be an important tool for policymakers in developing countries from all over the world. So that was the introduction of the Clean Energy Solution Center. Now we can start diving into the features of wind and solar PV directly, because this is what future electricity markets are all about. We will probably see a lot of countries around the world where the share of variable renewable energy sources will increase quite significantly, and therefore we first of all have to understand the important features of these technologies. One of them, of course, being that there's very high upfront investment costs, which is very much different to a gas-fired power plant, where the capital expenditure might be as low as 25 to 30%, and everything else is then being paid for purchasing the gas, maybe even the CO2 allowances that you might need. However, the ratio is very much the opposite when it comes to wind and solar PV. So you have a lot of upfront capital expenditure once you start the project, and then you have very little operational maintenance costs, and of course with wind and solar PV you don't have any fuel cost. which has very important implications for financing projects. Secondly, you all know that there is no fuel cost for wind and solar PV. The wind is for free and the sun is also for free. So they have also almost marginal, zero marginal cost, which puts them first in the merit order, which is a positive effect, which we will also discuss in this webinar. And then, of course, the biggest factor is as well that there's fluctuating supply. So even though our forecasting systems have improved, they are still dependent on the weather, and we need to provide backup capacity from either other technologies or other flexibility options. And this is actually the focus of this webinar today, a discussion of the various flexibility options that we have in today's and in future electricity and energy markets. And I want to walk you through some of these flexibility options in the next 35 minutes. In order to get it a little bit more visual, what will happen with electricity markets in the future, here's actually some graphs of the foreseen electricity market in Germany in 2022. So not so far from now. We will probably have a share of about 50% renewable electricity with high shares of solar PV and wind energy. And just from these graphs, you already see some of the issues that we will be facing with. So first of all, we might have some periods where we have an abundance of electricity, which is something that we're not yet used to, where if we assume that there's stable demand, then there will be oversupply of renewable electricity, and the question is how does the system deal with it? What you also see that there's quite a lot of variation in supply from variable renewable energies. So we also need to talk about this gray space, the residual load here, and who's going to jump in if wind and solar PV are not able to provide the electricity that we need at the moment in time. You also see from this graph, this is now a couple of months later, this is August, you can see that you actually have very steep ramps as well, especially with solar PV. You see that it goes up and down quite rapidly. That means that these the fossil fuel-based power generators also need to become a lot more flexible, and their ramping capabilities need to improve quite significantly. And last but not least, we can also look at the ugly months of November, especially in the northern part of Europe, in Germany. We sometimes have 3 weeks in a row with gray sky. It's very cold. There's no wind. There's no sun coming through the clouds. And then, of course, we also have to talk about solutions, how to provide the electricity from other power generation sources at these times when we don't have a lot of solar PV and wind energy in the system. So I think these graphical illustrations give you a pretty good idea of the challenges that we're actually going to face in many electricity markets around the world in the future. There are, of course, very fortunate jurisdictions and countries around the world, like British Columbia in Canada, for instance. They have an abundance of hydropower in their system, the same as Norway, so they can actually provide well, over 95% of their electricity needs with hydropower alone. So, of course, they have other problems and minor problems in relation to countries which will have to rely primarily on variable renewable energy sources such as wind energy and solar PV. So let's take a look at the options for increasing flexibility in the electricity markets that I would like to discuss with you today. So first of all, we're going to talk quickly about flexibility through grid expansion and increasing interconnections with neighboring countries. Secondly, we'll talk about more flexibility from conventional power producers, which could also, to a certain extent, be provided by dispatchable renewable energy producers, such as biomass producers or concentrated solar power producers or even geothermal power producers. Dispatchable means that you're able to produce the electricity when you actually need it, and that they're actually not weather dependent. Then there's also a certain amount of flexibility that you can harness from variable renewable energy sources. That's what we're going to discuss shortly. And then we will also discuss at the end of this presentation flexibility coming from more flexible demand, so demand response policies, and also flexibility through storage technologies, which are currently emerging in a lot of markets around the world as well. So this is the agenda for the next half hour, and we start by looking at grid expansion, and I just want to give you a few examples. First of all, an example from my home country, Germany, where we have an ambitious target for renewable energy in the future. We're currently at about 30% of electricity from renewable energies, and by 2050 we want to have at least 80% of renewables in the system, 2025 about 50%. So in order to get there, we have looked at the current grid infrastructure, and we figured that this is actually not sufficient in order to integrate increasing shares of solar PV and wind energy, because you need to know that most of the new deployment of wind and solar PV, especially wind energy, is actually happening in the northern part of the country, where the big load centers are actually in the southern part of the country, because most of the industry is located here. So this is why we've done some forecasting about which transmission lines we will need in the next decade in order to be able to transport the electricity from north to south, because currently we are in a situation where we see quite a lot of loop flows in the European electricity system. That means we want to transport the electricity from northern Germany to southern Germany, but since we don't have sufficient interconnection, the electricity is actually going through Poland, Czech Republic, into the southern part of Germany, and of course, as you can imagine, the Polish and the Czechs are not very happy with this. So there is an urgency in Germany to reinforce the transmission grid, but also to upgrade the distribution grid, because you know that most of solar PV is actually connected at the distribution level, and we need to have an general upgrade of the system, but also introduce bidirectional transformer stations, because sometimes we produce more electricity now at the distribution level that it actually has to flow back also to the transmission level. Which will also be the case with increasing surge consumption of solar PV in many other jurisdictions around the world. So these long-term scenarios, long-term grid expansion planning are very crucial when you set targets for renewable energies. I've worked in quite a lot of countries around the world where policymakers have set targets, but they have actually forgotten about upgrading the grid infrastructure as well. So then you run into a problem 2 or 3 years later that you no longer have the necessary transmission capacity available, and then you run into problems. So starting at a very early stage with transmission upgrade planning is very crucial for your overall success in transforming your electricity system. And this is not only happening at national scale, we actually also see this happening in the European electricity market, which is currently growing together. So on this map, you actually see important bottlenecks in the European electricity grid. For instance, here between France and Spain, there's a very limited interconnection between those countries, because there's a mountain chain there, but also because the local policymakers could not agree for where the new transmission line should actually go through, because it's a very sensitive area, high population density, and very sensitive natural environment. So it has been an issue for many years. So of course, the European institutions, the European Commission has now identified core new transmission lines that have to be built in the next couple of years in order to further increase the interconnections, which we want to bring to 10% at least by 2020 and 15% interconnection capacity by 2030, in order to really have a common, at least the physical requirements for a common European electricity market in the future. So the remaining bottlenecks need to be removed. And what is also happening in the European system is that we see a lot of linking of markets, what we call market coupling. So when you have a sufficient amount of interconnections, you can of course trade electricity quite easily in the Central European electricity market. And Germany, for instance, right now has a common merit order with with Austria, because it is assumed that the electricity flows from one country to the other are sufficient so that you can also trade the power in a common market. I think a very interesting approach is also what IRENA is currently proposing with the clean energy corridors, renewable energy corridors. They have promoted this already for the last couple of months in Africa, where they want to build actually a transmission line running through all of Africa, from Cairo to Cape Town, and that in this area you will have streamlined interconnection procedures, but also IRENA is giving advice on other important policy frameworks. So we've seen that including renewables into spatial planning and adopting clean energy corridors actually makes a lot of sense and will increase the ability of integrating higher shares of wind and solar PV in all of these countries, because then they can transmit the electricity from one country to the other and really alleviate certain bottlenecks. So that was, we could of course talk at least for 2 hours about grid expansion planning itself, but we already move on to the next flexibility options, which is more flexibility from conventional power producers or dispatchable power producers, which next to grid expansion is one of the largest sources of flexibility in current electricity markets, and is sometimes overlooked because many policymakers, when they think about renewables, frequently say, oh, well, if we have wind and solar PV, we need storage because we have so much fluctuation. But you actually have quite a lot of storage already in the system, and this is actually the fossil fuel that you burn, because when you have a ton of coal, this is actually electricity storage by itself. You just have to burn it at the right time, stop burning it when it is not needed. So you have to run your fossil fuel-based power plants according to the requirements, according to the existence or non-availability of wind and solar PV, and then you actually have from my point of view, the cheapest form of storage that you can probably get. But in order to do so, there are some technical and institutional barriers that need to be overcome. First of all, as I mentioned before, in future electricity markets, you will see a lot more requirements for ramping capability. So we see quite a few electricity markets around the world that have introduced new ramping products as well. For instance, in California, that means if you run a power plant who is able to ramp up and down really quickly, and this is what we need in the future, then you get additional payment for this. So here's just one approach which has been elaborated by Annual in 2012, where actually for this ramping period, the wholesale electricity market price can increase quite significantly in order to help the system, and this will also give them financial incentives for investors to only invest in power generation plants which have these ramping capabilities, because a lot of the existing power plants, especially lignite, coal, and nuclear power plants, are not very flexible in their operation. Of course, they can be upgraded, but this also comes at a certain cost. And sometimes for all coal-fired power plants or all lignite power plants, this is no longer possible. So for instance, in Germany, there are some of the old lignite plants which are already running for 40 years. They sometimes need up to 2 days in order to shut down completely and restart again completely. And of course, this is not the type of flexibility we need in future electricity systems. We need power generation sources which are much more flexible. This also brings us to a second point, and this is of course that we will probably no longer see baseload power plants in future electricity markets. It is sort of the end of baseload power plants. What we really need in the future is flexible fossil fuel-based power plants, and you can see this again from the graphics that I've already shown you, that in some periods, especially here, you see that there's no longer need for any fossil fuel-based power generation. So if they would run baseload, we would get into big problems. Either you would have to curtail more renewable energies, or you would have to introduce other flexibility options. But having a flexible fossil fuel-based power generation is definitely a prerequisite for future markets. What is also very important in this slide is the reduction of must-run requirements, because there's also a lot of fossil fuel-based power plants who need to run at a minimum, let's say, of 50% of maximum output. If they go below this, their efficiency decreases quite considerably, or they might have to be switched out altogether for technical reasons. So there might also be some technical upgrades of the existing power plants needed in order to avoid that we have a very steady must run of conventional power plants, which will actually lead to a lot of inflexibility in our future electricity system. And something that we can observe, of course, in all countries around the world which already have high shares of renewable energy sources, is that the full load hours of coal and gas-fired power plants, but also nuclear power plants, will be reduced quite significantly. And this brings us to a very complex debate on how they can still earn their money. So some people argue that some of the money that they get should actually come from capacity markets, because they won't be able to earn all their money on energy-only markets. In non-liberalized markets, in regulated markets, we more frequently see renegotiations of offtake agreements. For instance, in China, a lot of the coal-based power plants are running on long-term offtake contracts, which are very inflexible. So from my point of view, it is necessary to renegotiate some of them and tell them, okay, you can still run at certain moments of time when we still need you, but when we have a good supply of wind energy and solar PV, you will have to ramp down and get your compensation by other means. This is not only a problem in the developing countries. This is, for instance, also the case in California, where a lot of the gas-fired power producers still have long-term power purchase agreements, which cause a lot of inflexibility in theirs. And then it is, of course, also important to move to economic dispatch. As I said before, there's a lot of long-term power purchase agreements, which would mean that this block of gas-fired power producers, which normally comes at a later stage in the merit order, would actually be placed here. And then you would then start with the economic merit order. So moving from long-term power purchase agreements for fossil fuel-based power producers towards real economic dispatch would be very crucial as well for the future flexibility in our system. That will also mean that wind and solar PV, since they have marginal costs of almost zero, they would only have to be dispatched in times of negative market price. Talking about all this, in some countries we will have to fully decarbonize our electricity systems by 2050. Actually, when you really take the recommendations of the IPCC for real, that actually translates into a scenario where all developed countries will have to fully decarbonize their electricity systems by 2050. And that means, of course, that you no longer have the option of using a gas turbine or a coal-fired power plant for renewable energy backup. So we also have to start thinking more thoroughly about what flexibility options can actually come from dispatchable renewables, so that, for instance, ramping requirements on hydropower will probably increase, but even more expensive dispatchable renewables such as biogas and biomass will have to run according to load and not just base load all the time. There's some interesting movements here in Germany back in 2012 and 2014. They modified their the payment mechanisms for biogas and biomass. So instead of paying them a flat, fixed feed-in tariff payment per kilowatt hour, there's now a combination of payment per capacity plus revenues from the wholesale electricity market. So altogether, this should lead to a situation where you actually run your biogas power plant in order in line with electricity demand, meaning that if we have an abundance of solar PV and wind energy, the biogas plants will stop running, whereas when we have a lack of solar PV and wind energy, they will start running. Of course, you will also have to invest into some storage units then. They will have to get bigger, and these storage units, of course, won't be there for providing storage over several weeks. It will probably be rather short-term storage units. So that was just a quick overview of the flexibility from conventional power producers and dispatchable renewable energy technologies. I also wanted to highlight some flexibility from wind and solar PV themselves. First of all, as I mentioned before, the weather forecasting systems have improved quite dramatically, and also the forecasting errors for solar PV and wind energy generation have been reduced quite dramatically in the last decades. I still remember, for instance, in Spain when they really started scaling up renewables in 2004, 2005, the forecasting errors were still in the range of about 30%. However, then they have also introduced different electricity market design. That means more intraday markets, so hourly or even 15-minute based products that you can trade on wholesale markets. And by having these various gate closure periods, you're actually moving making it much easier to forecast electricity generation from wind energy, because it's much more easy for me to predict how much electricity I will produce from a wind generator in 15 minutes from now than, let's say, in 1 week from now, which was a requirement at an early stage. So by simply changing the design of the electricity market to this effect, we were able to reduce forecasting errors for wind and solar PV quite dramatically. And of course, it also helps if you bundle forecasts on a regional basis, because this will also help you to alleviate system or plant-specific forecasting errors. So it's usually more effective to forecast electricity generation for wind energy in an entire region than doing it just for one wind energy power plant. What is also very crucial is that wind and PV can now help to stabilize the electricity grid, because the modern technology is able to support the electricity grid by voltage ride-through capabilities, and also providing reactive power. This is sometimes simply required by the new grid codes. Sometimes you even get additional payment for providing these, because not yet all technologies on the market can do so. And what is also crucial is that you look into the design of your ancillary services market again. For instance, in Germany, we had a situation where you could only participate when you were able to provide a certain amount of electricity, which was far too high for a lot of small-scale renewable energy producers. And again, the bidding times were quite far before the actual power generation would need to take place, a week before. And this would, well, by definition, exclude renewable energies, because, as mentioned before, it is much more difficult for me to predict how much power I will produce from a solar PV plant in 1 week time than it is tomorrow or just a few hours. So once again, by just changing the design of the ancillary services market, we were able to get a lot more flexibility also, and system support from wind and solar PV. And what we also see in a lot of countries around the world is that solar PV and wind energy producers are now much more confronted with price signals from electricity markets, where most countries had fixed feed-in tariffs in the last decades. We're now moving more to premium feed-in tariffs or to bilaterally negotiated offtake agreements, which also take actual load and power demand into account. So I think this is an important development. At the same time, you always have to keep in mind that the ability of a wind power producer to really run in accordance to demand is rather limited because it's still weather dependent. So what they can do, of course, is to reduce the power output at certain moments of time, but it is much more difficult for ramping up if they want to also increase the power output of a wind plant in general. What we also see in many electricity markets around the world is that we're moving from priority dispatch to economic dispatch. So under many feed-in tariff mechanisms, we have priority dispatch. Under the premium feed-in tariff, of course, in times of negative spot market prices, which is usually a result of a combination of high shares of renewables and very inflexible conventional power plants. So the must run that I mentioned before of some conventional power producers. So in those situations, of course, where the electricity market price goes below zero, you would, of course, reduce the output of your wind power plant, of your solar PV plant. And in order to do so, of course, you need to have the technical means. That means you need to be able to remote control the power output of your new power generation. And very much related to this is are the new curtailment rules that we see emerging in different markets around the world. So previously we were primarily curtailing, that means shutting down renewable energy producers in times of grid congestions when you were no longer to transport the electricity from the location where it is produced to the load centers. What we now see in some European countries is also modified grid planning, that you're actually no longer building up on your transmission and distribution grid to an extent that you're able to transport each and every kilowatt hour that might be produced from a wind power generator or from a PV producer, but instead limited to 95% of the wind power park output. And this way you can actually also decrease the cost for your system expansion quite considerably. Another option, and here's an example from Texas, where you can actually see that by having remote controlled renewable energy plants, they were actually able to reduce the output of some of their wind parks at a certain moment in time when it was no longer needed, and then increase it again when there was no longer a need for renewable energy dispatch. Germany, in the case of PV, is taken a bit different approach, because especially small-scale solar PV systems normally are not able to be remote controlled. Systems below 100 kilowatts sometimes don't have the technological means. So what they did in this case is limiting solar PV output to 70% of the PV nameplate capacity. That sounds quite a lot, this 30% reduction, but actually the very peak of the solar PV output is rather limited in comparison to the overall output of the PV system. So by limiting it to 70% of the nameplate capacity, that reduced the total power output of solar PV systems by around 3 to 5%, which of course reduces the revenues for the solar PV producers a little bit, but at the same time it puts a lot less pressure on existing distribution and transmission systems in Europe. The big question is, in all of these cases, are renewable energy producers fully financially compensated if they are curtailed? There's different regulations around the world. Normally, in case of curtailment due to grid congestion, they're fully compensated, and in other situations, this might not be the case, because if they're not fully compensated, this might also give an incentive of building your renewable energy power plant in a location where today and in the future you will face less grid However, that's very difficult to foresee how the electricity system will develop, where there might be future grid congestions. It's very difficult for a system operator and investor to do this calculation over a 20-year period. So this is why I normally recommend full compensation in terms of curtailment of renewables. Now let's move to some less used flexibility options that we have, especially in future electricity systems. And one of them is, of course, flexible demand. Most of the policies are currently targeting flexibility in the industrial sector, because this is normally where most of the demand is taking place. So instead of dealing with millions of small-scale residential customers, you only have to find arrangements and create policies for, let's say, the 50 largest electricity consumers in your country. And if they are running a business like a steel mill, which consumes a lot of electricity, where there's a certain amount of flexibility available of ramping up and ramping down the production process, then you know rather low-hanging fruits here when it comes to demand response policies. So you have different types of demand response. One of them is, of course, load shifting. The other one is load shedding. That means reducing load or load increase. If you remember this one graph where we had an oversupply of solar PV in the system in Germany in 2022, of course, when you have very low electricity prices, you can also imagine that in these periods, electricity demand might go up. So if you're a large-scale electricity consumers become more flexible, if they also modify their production cycles in a way that they have the technological availability to become more flexible, then there might be quite a lot of potential in these sectors. So the big question is whether they need special financial incentives in order to do so, or whether market prices alone, as you can see here, will actually be able to incentivize the required flexibility. There's also different approaches. You have a lot of states in the United States where demand response providers can also participate in capacity markets, so they get some additional capacity payments. In many European markets, instead, the regulators are saying, no, we're actually hoping that our electricity prices will get a lot more spiky in the future, because we have more variability of solar PV and wind energy and less policy intervention. And once you have spiky electricity prices, then the demand side, your large-scale consumers will have a big incentive also of becoming more flexible in electricity demand. So that's almost a philosophical question, which is the best regulatory approach for incentivizing demand response. I think there will have to be a combination of both. First of all, spiky electricity markets, but for some types of industries, if you really want to also make important upfront investments in changing their manufacturing processes, and they might also need some additional financial incentives. Next to the typical types of load shedding and shifting, there's of course also a lot of flexibility coming from power to X, so sector combination. Power to transport, electric vehicles will play a crucial role, power to gas. Here's just one example for power to heat, which in many developed countries, colder developed countries, is considered a very cost-effective source of flexibility, because when you're running your heating with a heat pump, this can actually do all three types of demand response that we discussed before, and you will be able to increase the load in certain moments of time, maybe also do load shedding, probably not for a couple of weeks or months, but at least for a couple of hours, and also a certain degree of load shifting. For the sake of time, let's move to our last flexibility options, which is discussed quite considerably by policymakers all over the world. as I mentioned before, that many policymakers have the idea in their head that in order to get to higher shares of wind and solar PV, they need to invest into storage directly. However, a lot of research, both in Europe and also in the US, has shown that you can actually get to very high shares of renewables, and we're talking about 50, 65%, without investing into new storage technologies, because you already can make use of all other 5 flexibility options which I've just introduced to you. So expanding the grid, making better use of conventional power plants, running them more flexibly, curtailing renewable energy sources, having demand response, and then the need for storage is actually rather limited. However, in some markets, for instance, the residential solar PV market, there might be, and there will probably be an emergence of battery storage in the next couple of years, because well, solar PV gets less expensive, storage gets less expensive, and there will be an increasing incentives for prosumerism. I mean, self-consumption of solar PV and battery systems in households. So generally speaking, storage technologies can provide a lot of the services that we need in future electricity markets. They can, of course, do load shifting, which is their primary raison d'être, but they can also help with frequency response. They can help to reduce grid congestion. They can also help to reduce renewable energy curtailment that we discussed before. And last but not least, they're very good. Some battery storage technologies are very good in providing very, very quick ramping, which cannot be provided by fossil fuel-based power generators in several milliseconds. So all of this always has to be considered in light of their cost. Currently, the storage market is highly dominated by pumped hydro storage, as you can see from the latest assessment from the International Energy Technology Roadmap 2014. There are, of course, there is an emergence of alternative new storage technologies, and there will be, this will be increasing in the next couple of years, but always keep in mind that most of the storage we're having right now, and also for the next decade, probably will come from pumped hydro. So as I mentioned before, the need for these flexibility options actually highly depends on the flexibility options that you have in the system. So you have to do an analysis of the availability of flexibility options in your country. And if you, for instance, I was on the Philippines a couple of weeks ago, so when they think about flexibility options, they think a lot about battery storage, because on the small islands, they don't have interconnections with the neighboring countries. They have very inflexible fossil fuel-based power generators, usually very old diesel generators. They can, of course, make to a certain extent a use of curtailment of renewables, but they only have a very limited amount of flexibility in the system. So from their point of view, of course, new storage, electricity storage, already makes sense as of today, and not only in 2 or 3 decades from now. Since we only have 12 minutes left here, already my conclusions, which I'm happy to discuss with you afterwards. So first of all, increasing the shares of wind and PV will increase the need for flexibility. I think that's very clear to each and every policymakers around the world. What is less clear is a very important amount of flexibility options that we have, and that you should actually do an analysis in your country, in your region, which of these flexibility options are the least cost options. And saying this, we always have to keep in mind that the cost competitiveness between these flexibility options might also change in the future. So whereas grid expansion is still considered to be a very cost-efficient way of integrating high shares of renewables in many countries around the world as of today, this might not be the case in 20 years from now, when distributed storage, battery storage plus distributed generation from PV has become even less expensive than it is today. So you can do the analysis of the flexibility options today, but you should probably do an update every now and then, every 5 years or so, and not to see whether there has not been important changes from the technological perspective. And what is very important to know is as well that many countries around the world already integrate very high shares of renewables. Denmark is a very important example with almost 40% primarily from wind energy in their system. Of course, they have a lot of flexibility in their system because they have very good interconnections with their neighboring countries. They have very flexible gas turbines, plus a very good combination with their distributed heating system. So they're in a very favorable condition. But even other countries like Spain, which is more or less an electricity island, they have been able to integrate more than 20% of wind and solar PV in 2014. So what we did in this webinar in these 45 minutes is discuss future electricity systems from the point of view of flexibility. What we did not discuss is future electricity market from the point of view of resource adequacy and security of supply, where we would have to go much deeper into the discussion of capability markets, capacity markets, and system planning as well. But I think that will be dealt with in another webinar. I also provided quite a lot of further reading for you. There's a lot of material out there on future electricity market design. So that was my presentation, and now we still have 10 minutes for discussing your questions. Thanks a lot for listening.